when we're solving equations like these, there's a couple things we want to do when we get started. They're just reminders that we want to get the variable by itself. So what do we do to remind ourselves of that? We circle the variable. And also a reminder of the golden rule. Whatever we do on one side, we have to do on the other. What's our reminder for that? The line of equality, right? So for every one of these, we're going to circle the variable. We're going to draw a line of equality before we do anything else. All right, so in the first one, I want to get W by itself. I want to remind myself that whatever I do on one side of the equal sign, I have to do on the other. So I do those two things. And then what do I have to get rid of to get that W by itself? The -1, right? How do I get rid of that one? We're going to add 1. So the opposite of -1 is +1. So we add 1. That's going to get rid of the -1 over here. But if we do it on the left, we have to got to do it on the right also to keep it balanced. All right, so on the left side, those ones are going to cancel each other out, which leaves what? W. And on the right side, we have -7 plus 1. So we have a negative and a positive. So when we combine them, is it going to get bigger or are they going to cancel? They're going to cancel, right? When we have negatives and positives, they cancel, which means we're going to subtract. 7 minus 1 is 6. And is it going to be a positive 6 or -6?
Negative.
Why? Yeah, the 7's bigger, and it's negative, so our answer is going to be negative. So on the next one, we want to get x by itself and draw our line of equality. So what do we have to get rid of to get x by itself?
6.
By doing what?
Subtract.
Subtract 6, and we'll do that on both sides. So on the right side, those 6's cancel, leaving x. On the left side, 4 minus 6. Okay, so it is going to cancel since we have positives and negatives. So we subtract and get 2. Is it a positive 2 or negative 2? Negative 2 because? Yeah, the 6 is bigger and the 6 is negative. Alright, next one, we want to get the y by itself. So we circle that, we draw our line of equality. And to get the y by itself, we have to subtract the 29. So we subtract 29 from both sides. Is the subtraction on the right side set up correctly? Do we have the bigger number on top? Yeah, that's fine. So what we need to do is subtract now. Can I do 7 minus 9? No. So what do I need to do? We're going to have to borrow, right? So I'm going to borrow from the 1 in the tens place, make that a 0, and make this 7 a 17, right? Did I do that correctly? So then we have 17 minus 9 in the ones place, which is 8. Okay. Then I have 0 minus 2 in the tens place. Can I do that?
No.
Okay, so I'm going to have to borrow again, right? So I borrow from the 200, make it a 100, and make this 0 a 10. Okay, so we have 10 minus 2 in the tens place, which is 8. And then in the hundreds place, I have 1 minus 0, right? 1 minus nothing, which is going to be 1. And then is that going to be a positive 188 or a negative 188? Positive. Why? Yeah, exactly. The 217 is bigger than the 29, and the 217 is positive, so our answer is positive. Next one, we want to get the z by itself, so we'll circle that, draw our line of equality. We need to get rid of that 48 by doing what? Add 48. So even though this is addition, we're adding a negative, which is the same as subtraction. So to get rid of it, we're going to have to add. All right, so we add 48 on both sides. And so over here, those cancel and we get z. On the left side, are we going to combine or are we going to cancel? Combine. So we'll add them together. 1 plus 8 is 9. 7 plus 4, 11. So we drop our 1, carry the 1. And 1 plus 1, 2. So we get z equals 219. Now the next 4 problems we're going to have to use multiplication and division. So this is what we did yesterday. All right, we start the same as we did before. So we circle the variable and we draw our line. But now this is a times 2, so to get rid of the 2, what's the inverse of multiplication? Division. So we're going to divide. What do we divide by? 2 or negative 2? 2, right? So we want to get rid of a times 2. The inverse of multiplication is division, but we have to divide by that same number. So we divide by 2. And if we do it on the left, we have to do it on the right. So on the left side, those 2's cancel because it's a times 2 and a divided by 2. And that leaves us what? A. And then on the right side, 16 divided by 2 is 8. Alright, next one, we want to get B by itself, draw our line of equality. We need to get rid of that 5. What's the inverse of division? Multiplication. So we're going to multiply by 5. Okay, we can put it there if we want, or you could put it out here if you want. It's really up to you on this one. If I multiply by 5 on the left, I have to multiply by 5 on the right. So on the left side, the divided by 5 and times 5 cancel, leaving what? B. And then on the right side, 9 times 5 is 45. And if you have trouble remembering that, you have that multiplication chart to use, right? Okay, 2 more. Next one, we want to get C by itself. What operation are we doing here with the 7 and the C? That's multiplication, exactly. The inverse of multiplication is division. So we're going to divide. Should I divide by positive 7 or negative 7? Positive 7. We just divide by the number that we multiplied by, right? So we divide by positive 7 on both sides. So our times 7 and divided by 7 cancel, leaving what? C. And on the right side, 63 divided by 7 is 9. All right, last one. We have 37 equals D over 9. What does that D over 9 mean? It means division. So it's D divided by 9. So what's the inverse of dividing by 9? Multiplying by 9. So we're going to multiply by 9 here. And if we multiply by 9 on the right, we have to multiply by 9 on the left. And this looks like a problem we're going to have to do a little work on. So the 9's cancel. That leaves D on the right side. That part's easy. But over on the left, let's stack them up to do that math. So we got 37 times 9. So what is 9 times 7? 63. Okay, so we've got our 3, carry the 6. What's 9 times 3? 27 plus 6? 33. Okay, so we get 333. Is that right?
Yes.
It's a fun number.